This video is the review for the Algebra 2 CP 2012 final non-calculator portion. I'm going to go as quickly as I can. If I'm done before 5 o'clock, I'll probably just do all the non-calculator on one. Otherwise, this will be split. 1a, what type of function is it? That is exponential decay. It's an exponential function. The y-intercept is approximately 0, 1.5. I don't have any way to really know without knowing what the function is. It has no zeros, never does cross the x-axis. The x-axis is an asymptote. The domain of any exponential function is all real numbers. And the range is all the positive values. Y is greater than 0, sometimes written as 0 to infinity if you're using interval notation. B is a logarithmic function. It has no y-intercept. It looks like it has a 0 at 1.5, 0. Don't know exactly. The domain is all positive numbers. I can write that as x is greater than 0. I can also write that 0 to infinity. The range is all reals. C is a quadratic. The y-intercept appears to be 0, 9. It's hard to tell, but it just looks like it's x minus 3 squared. I'm sorry, x plus 3 squared. And so the y-intercept would be at 9. The domain is, the zeros. Looks like you have a 0 at negative 3, 0. The domain is all reals. And the range is all positive numbers and 0. So I would either put y is greater than or equal to 0, or I would put 0 to infinity but have the 0 as a square bracket. Number line analysis to solve the problems. 2a, if I draw a number line, my zeros are going to be at 3 and at negative 2. I'm going to pick a number greater than 3, like 4. If I pick a number like 4, the first factor would be positive, the second factor would be positive. Any number greater than 3 must be positive. If I were to do this a couple more times, you'd find this one's negative and this one's positive, either by noticing that this is a quadratic or by trying each individual piece. Where is this graph less than 0? The answer is negative 2 to 3. The second one, I draw the number line. I have a 0 at 0. I have a 0 at negative 1. And I have a 0 at 7 halves. Because the entire function is positive, if I picked a number bigger than 7 halves, any number bigger than 7 halves would give me a positive y value. That would make this one be negative, this one be positive. Because I have a bounce at negative 1, this would be positive. You can certainly try a number in all of 4 of those intervals. Where is this graph greater than or equal to 0? From negative infinity, look, it goes all the way through the negative 1 to the 0, picks back up at 7 halves, and goes on to infinity. Number 3, divide x squared plus 3x plus 2 by x plus 5. I'm going to use synthetic division. Here's my negative 5. I put a 1, 3, and a 2. I'm going to drop my 1, gives me a negative 5, gives me a negative 2. Negative 2 times 5 is 10, gives me a 12. My answer is x minus 2 with a remainder of 12, or x minus 2 plus 12 over x plus 5. The quotient is x minus 2. The remainder is 12. If I had taken my negative 5 and used that and plugged it into x squared plus 3x minus 2, let me write that down, x squared plus 3x, plus 2. If I plug in a negative 5 for x here and a negative 5 for x here, negative 5 squared is 25. 3 times negative 5 is negative 15 plus 2. 25 minus 15 is 10. 10 plus 2 is equal to 12. That's how I use the remainder theorem to know my remainder was going to be 12. Number 4, equation of vertical asymptotes, holes. Let's just do all these things. For A, I have 2 points of discontinuity. I have a point of discontinuity at negative 2 and a point of discontinuity at 3. Because x plus 2 is not a factor in the top, this is a vertical asymptote. My vertical asymptote is at x is equal to negative 2. Because the x minus 3 factor does show up in the numerator, I'm going to have a hole here because of their same degree, and my hole is going to be an ordered pair, a coordinate point 3 something. The way I'm going to figure out what the something is I'm going to get rid of the information that caused the hole and plug a 3 in, and I would get 2 times 3 plus 1 over 3 plus 2, which is 8/5. My hole is at the ordered pair coordinate point 3 8/5. The equation of the horizontal asymptote. The numerator has degree 2, the denominator has degree 2, so it's neither top-heavy nor bottom-heavy. The coefficient of the numerator is 2, the coefficient of the denominator is 1, so I have a horizontal asymptote at y equals 2. To find my x-intercept, I can get rid of any information that gives me the hole. I can get rid of any information in the denominator, set whatever else is left equal to 0. 2 can't be equal to 0. X plus 1 equals 0 tells me x is equal to negative 1. And so I have an x-intercept at negative 1, 0. To find my y-intercept, I'm going to set x equal to 0 and solve. I don't need the information that gave me the hole because it's going to be the same on the top and the bottom. Here I have 2 times 0 plus 1 is 2 times 1, which is 2. In the denominator, I have 0 plus 2, which is 2. 2 over 2 is 1, and so my y-intercept is the ordered pair 0, 1. That's my answer for A. Let's look at B. For B, I'm going to factor out the denominator, and I get x minus 3 over x minus 3 times x plus 5. Has 2 points of discontinuity, 3, which is going to be a hole. If I mark out the part that gave me the point of discontinuity, I have an implied 1 on the top. 1 over 3 plus 5 is 1/8, so my hole is at 3 1/8. Then I need to find out my vertical asymptote. That is going to be at the other point of discontinuity. X is equal to negative 5. Horizontal asymptote. This graph is bottom heavy. The degree of the numerator is 1. The degree of the denominator is 2. If it's bottom heavy, I have a horizontal asymptote at y equals 0. To find the x-intercept, I get rid of everything in the numerator and denominator that are going to cause me a hole, get rid of everything else in the denominator. I'm left with absolutely nothing. I have no x-intercept. Does not exist. To find my y-intercept, I'm going to plug in 0 for x and solve. I don't have to worry about these pieces. Have an implied 1 on the top. 0 plus 5 in the denominator is 5, and so my y-intercept is 0 1/5. Pretend that's a 5. Let me try that again. 0 1/5. Number 5, I'm going to simplify the following equations. For A, let me go ahead and write it as prime factors. If you do a prime factorization for A, you would get a 2, a 2, a 2, a 3, 1, 2, 3. I can't tell if that's, I'm assuming that's 5 x's and 4 y's. Every time I have 3 alike, I can actually combine them as 1 and set them outside the radical. I have 3 2's, which is 8. The cubed root of 8 is 2. I have nothing for the 3, so I'm going to keep it inside the radical. I have 3 x's. They'll become 1 and become x on the outside. Leaves me with 2 x's underneath the radical. and I have 3 y's, so one of those y's will go outside and the other y will stay inside the radical. My answer is 2xy times the cubed root of 3x squared y. Square root of 8, x to the 4th, y to the 7th. If you do the same thing, your answer will be 2x squared y cubed times the square root of 2y. And for C, 64 to the 2/3, that's the cubed root of 64 squared, right? Take the bottom root of the number and then take it to the top power. The cubed root of 64 is 4, and 4 squared is 16. Number 6. In order to solve this equation, I need to isolate the radical. So the first thing I'm going to do is subtract 3 from both sides. I'll get 2 times the square root of 4x minus 3 is equal to 10. Dividing both sides by 2, the square root of 4x minus 3 is equal to 5. Now that the variable is isolated, we can square both sides. 4x minus 3 is equal to 5 squared, which is 25. So 4x is equal to 28. X is equal to 7. F of x minus g of x, just subtract. I'm going to do 3x minus 5 minus 2x minus 1, which is the same thing as plus a negative and plus a positive. 3x minus 2x is x. Negative 5 plus 1 is negative 4. My answer is going to be x minus 4. F of x times g of x, we're going to do 3x minus 5 times 2x minus 1. When I distribute, I get 3x times 2x is 6x squared. 3x times negative 1 is minus 3x. Negative 5 times 2x is minus 10x. Negative 5 times negative 1 is plus 5. I get 6x squared minus 13x plus 5. C, g of f of x. Well, g of x is 2x minus 1. Whatever I have for x, I'm going to plug into the function. Well, in this case, what I'm trying to plug into that function is f of x, which is 3x minus 5. Now distributing out, I get 6x minus 10 minus 1 is 6x minus 11. D of f of x. F of g of x, this time I'm going to do the f of x function, which is 3 times some sort of number minus 5. Well, what number am I plugging in? I'm plugging in an expression, g of x, which is 2x minus 1. Distributing out, I get 3 times 2x is 6x minus 3 minus 5, which is 6x minus 8. Number 8. Natural log is my parent function. Notice in A, the 3 is associated with the x, so it's moving left or right. Things in parentheses are always backwards of what you expect because it's actually an implied negative, natural log of x minus negative 3. So this graph is actually moving left 3. The second graph, the 3 is associated with the y value, not the x value. It's not in parentheses, so it does what you would expect. It goes up 3. And this one is multiplied by a scale factor of 3. Find the inverse. This is for A. We've got y equals x plus 3 over 2. To find the inverse, you switch the x and the y's. So x is equal to y plus 3 divided by 2. So 2x is equal to y plus 3. Y is equal to 2x minus 3. For B, y is equal to 5x minus 4. Switching the x and y, x is equal to 5y minus 4. Adding 4 to both sides, and then dividing by 5, we get y is equal to x plus 4 divided by 5. For C, we get y is equal to the log base 3 of x. Switching the x and y, x is equal to the log base 3 of y. I'm going to undo the log base 3 by taking 3 to the power both sides. 3 to the x is equal to, these cancel out, y. Y is 3 to the x. And dy is equal to e to the x, switching the x and y's, x is equal to e to the y. I'm going to undo e to the power by taking the log base e, which we call the natural log. So I'm going to take the natural log of both sides. These cancel out. Y is equal to the natural log of x. Number 10a. Hopefully you'll notice now the natural log and e are inverse functions. They cancel out. I'm left with 5. For b, I'm going to take the log base 3. I can write 1/27th as 3 to the negative third power. These cancel out. I'm left with negative 3. For c, I'm going to actually use the product rule and the quotient rule for logarithms. I can write these as 1 log. I'm going to get the log base 6 of 3 times 12, because there was a plus sign, divided by, because there's a minus sign, 36. Well, that's the log base 6 of 36 divided by 36, which is 1. 6 to what power is equal to 1? The answer is 0. So the answer to C is also 0. Number 11a, I'm going to get a common base for both, and so I've got 5 to the 3x minus 2. I can write 125 as 5 cubed. Taking the log base 5 of both sides, 3x minus 2 is equal to 3, so x is going to be equal to 5/3. For b, I have an implied base of 10. I'm going to write this as an exponential function. 10 to the 3 is equal to 4x. So 1,000 is equal to 4x. So x is equal to 250. I'm going to do the same thing with c. 3 to the 2 is equal to x squared. So 9 is equal to x squared. Taking the square root of both sides, x is equal to plus or minus 3. Number 12, x-intercept and y-intercept. How do you find the x-intercept? You set y equal to 0. So I'm going to get 0 is equal to 5 to the x minus 25. 5 to the x is equal to 25. X is equal to 2. So my x-intercept is 0. To find the y-intercept, I'm going to set x equal to 0. Y is equal to 5 to the 0 minus 25. Well, what is y? 5 to the 0, it's 1. 1 minus 25 is negative 24. So my x-intercept is 0, negative 24. Log base 2x plus 1. To find the y-intercept, I'm going to set x, let's do the same order. To find the x-intercept, I'll set y equal to 0. So 0 is equal to the log base 2 of x plus 1. Let me 2 to the power both sides. 2 to the 0 is equal to 2 to the log base 2 of x plus 1. Well, 2 to the 0 is 1. 1 is equal to x plus 1. So x is equal to 0. So I get 0, 0. Maybe we'll just check that by trying to go the other way around. Let's set x equal to 0 and see if we get a 0 for an answer also. Y is equal to the log base 2 of 0 plus 1. Y is equal to the log base 2 of 1. 2 to what power is equal to 1? The answer is 0. Sure enough, 0, 0 is the x-intercept and the y-intercept, crosses right through the origin. Determine whether I've got exponential growth or decay. First things first, the number I'm raising to the power is greater than 1. 2.718-ish is what e is. So that keeps me growth, but I have a negative in front of the x that changes this one to decay. For 13b, the number I'm raising to a power is less than 1, changes to decay. There's no negative in front of the x to change it back. So b is decay. For 3, the number, or c, 3 is bigger than 1, so I don't change from growth to decay, but there is a negative in front of the x. All three of these for exponential decay. 14. Suppose x and y vary inversely. That would mean that y is equal to k over x, where k is some constant of variation. Well, in this case, 2 is equal to negative 6 over x. I can switch these two to say x is equal to negative 6 over 2. I'm sorry, what am I doing? I didn't want to go over x. Scratch that. Let's try it again. 2 is equal to k over negative 6. Multiplying both sides by negative 6, k is equal to negative 12. 15. Simplify the expressions. I'm going to multiply a, I'm going to multiply by x, and so I'll get x squared over 3x. On the right-hand side, I'm going to multiply by 3. 3 times 3 is 9 over 3x. And so I end up with x squared minus 9 over 3x. For b, I can factor x squared plus 2x as x times x plus 2. I can factor x squared minus 4 as x plus 2 times x minus 2. So if I multiply through, my least common denominator is x times x plus 2 times x minus 2. I'm going to multiply that scratch that. Let's do it the other way I want to do here. So I'm going to multiply the first one by x minus 2 over x minus 2. And I'm going to multiply the second one by x. So I get x times 3 over, well, I already had x plus 2, x minus 2. I'm going to multiply it by x. So I end up with x squared minus 2x plus 3x over x times x plus 2 times x minus 2, which is equal to x squared plus x over x times x plus 2 times x minus 2, which is equal to x times x plus 1 over x times x plus 2 times x minus 2. Canceling out the x, I get x plus 1 over x plus 2, x minus 2. For c, I have a common denominator, so I can actually write this as x squared plus 8x plus 7 divided by x plus 5. Much easier. I didn't even manage to mess that one up. 16. Conic section as a circle, ellipse, hyperbola, or parabola. In my order, I look to see if it's a parabola first. I look to see if it's a hyperbola second, an ellipse third, a circle first. I look to see, first of all, is there an x squared and a y squared term? For a, there is, so I know it's not a parabola. I look to see if the coefficient of the x squared and y squared terms are opposite sign. They are, so I know that 16a is a hyperbola. For the second one, do I have an x squared and a y squared term? No, I don't. That's a parabola. And for c, I look to see, do they have an x squared and y squared term? They sure do. So it's not a parabola. Are they opposite signs? No, so it's not a hyperbola. Do they have different values? No, they're both 5. It's not an ellipse. This must be a circle. Center, vertices, and covertices of the graph modeled by this equation. Because there is a plus sign, I know that this is an ellipse. And so, look, the center of my ellipse, 0 goes with the x, 1 goes with the y, so 0, 1 is my center. Because 81 is bigger than 25, I know my major axis is horizontal. It goes out left and right. How much? The square root of 81, which is 9. So my vertices are going to go left and right 9 from the center, plus or minus 9, 1 would be my vertices. My covertices are going to go the square root of 25 out, which is 5. I'm going to go 5 up and down from the center, and so my covertices are going to be 0, 1 plus 5 is 6. 0, 1 minus 5 is negative 4. And let's see, it didn't ask for my foci. I could find my foci by doing 81 minus 25, taking the square root, and going up and down from that number. Center vertices of the graph modeled by this equation. Because there is a minus sign here, this is a hyperbola. And because the x value is first, I know it opens right and left. So if all I have to find is the center and vertices, the center is going to be 1, 0. And I'm going to go out 5 left and right from 1, 0. So my vertices are 6, 0 and negative 4, 0. We could draw these asymptotes, but in this case it didn't ask, and since I'm almost out of time here, I'm going to go flying on. Which way does this parabola open? Well, it's an x equals y squared. Because it's x equals y squared, it opens left or right. Is my a value positive or negative? I have a negative 1/2, so it opens left. And number 20, the equation of the circle. The first one is going to be x minus negative 4 squared, which is x plus 4 squared, plus y minus 0 squared, which is y squared, is equal to the radius squared, which is 16. The second one, I will get x minus 2 squared plus y plus 8 squared is equal to 2 root 3 squared. When I square one with a radical, I multiply this number by itself, giving me 4. Multiply it by the inside number, gives me 12. That's the end of the non-calculator portion. I will do the calculator portion in just a few minutes and try to put it up on the website at the same time.